Alrighty, this is a pulley problem here, okay? And basically for the pulley problems, step zero is calculate stuff, right? Right. Step one is to set up F equals ma for both masses, right? They're going to set up an equation for this and this, right? And then somewhere in there, we have to decide which way positive A is. Okay, so for this thing, I'm actually going to assume that this thing accelerates this way and this way. In fact, that's what the problem says. If you read the whole thing, it says it's just, this thing's descending, this thing's sliding to the right. Okay. Okay, so three steps, right? We're going to calculate stuff. I think what we need to know, there's a couple things we need, right? The first is that there's going to be a force of gravity down on this. So let's figure that force out, right? And that's going to be 18 times 9.81. Okay, so 18 times 9.81 is 176.58. Okay. The other thing that we want to do is to figure out the dynamic force of friction there, right? So the force of friction is R times the coefficient, right? Which is going to be 0.112 times 35 times 9.81, right? So here we go. So 0.112 times 35 times 9.81. And that's 38.4552. Okay, let me just double check that. Yeah, that's what I get. So we've got these two forces there, so that we've done this. We've calculated obvious relevant things, right? Okay, the next is to decide which way positive acceleration is. So I'm going to make to the right positive, no big surprise there, but here this is going to be somewhat surprising. This downward direction here is going to be positive. Okay, so that makes this force here positive. Okay, and the reason it's positive is that the acceleration's down, and we want the positive force to be in the direction of the positive acceleration. Okay, since down is positive, this guy's positive. Okay, now there's going to be another force acting on this guy, and that's the tension in the string. It's one of our unknowns. I'm purposely drawing that arrow shorter than this arrow, right? So I'll call that guy T. T is just tension. Tension is just the force in a string, right? And then this guy here, since he's sliding to the right, has a force to the left. And I'm purposely drawing this arrow shorter than this arrow, right? That's this 38.4552. Okay, and the reason that the friction is to the left is that this guy's sliding to the right. Okay, and then the tension, and I'm trying to draw these guys as being congruent, right? This tension is also acting to the right. So that's the weird thing, right? Is the tension pulls this guy to the right, also is pulling this guy up, because that's the way strings work, right? They pull. If I'm pulling and you and I are both holding at ends of a string, right? And we pull. Each of us feels the force acting toward the other person, right? So this tension acts to the right. This guy's acting up like that on this thing. Okay. Now, if this is the positive direction, right? Then that makes this thing positive, but that makes this guy negative. Okay, that makes this guy positive, but this tension here is negative. Okay, because we're assuming that the acceleration is that way and this way. Okay. Okay, so now what we do is we set up two equations and two unknowns for this, right? So for the 35 kilogram object, our F equals ma looks like this. Tension minus 38.4552 equals 35A. And for the 18 kilogram object, we've got 176 minus tension equals 18A. Okay, now what we're going to do, I mean, there's lots of ways. This is a system of equations. There's two unknowns and two equations, right? T, the tension, and A, the acceleration, right? So we're just setting up, this is F equals ma. Okay, and there's lots of ways to solve this. We could use matrices, we could solve this one for A or T and substitute it in here. But notice that we've got a positive T and a negative T. So whenever you see stuff like that, you can just simply add the two equations together. So 35A plus 18A, 35 plus 18, that's approximately 53A. Okay. And then if we add these together, you've got T and negative T, so you end up with 176.58 minus 38.4552, right? So combining these, the T and the negative T go away. This is how you eliminate that variable, okay? And we don't even need to multiply one of these equations by anything to make it linearly combinable, okay? And now we're set. Now we can just divide this side by 53. And we can get A. So here we go. So clear parentheses, 176.58 minus 38.4552. Right parenthesis divided by 53. Hopefully we get 2.61. Whoa, what did I just do? That is weird. Okay. Oh, I see what I did. I did something totally different. Okay, hold on. Okay. Okay. Are we ready for this? 2.61. Okay. My acceleration is 2.606. I actually got something like 4,000 or something when I did that by typing something wrong. Okay. So that's 2606. Sorry. That's a 6. Okay, meters per second squared, so about 2.61, this is right. Okay, so now we want to figure out what the tension is, and so I guess what I'm going to do is use this guy here. Okay, so tension equals 35A plus 38.4552, right? So if I plug that acceleration in there, right, if I go 35 times the answer I've got plus 38.4552, I get the tension is 129.66. Okay, so what I typed in here was 35 times 2.606 plus 38.4552, and I got this for my tension, right, which agrees with this. Okay, now finally what I'm going to do is take this equation here, and let's just try that, right? Let's go 129.66. What am I doing? I'm doing this guy here. I'm going to go 176.58, okay, minus 129.66. What does that equal? 176.58 minus the answer I just got. I get 46.91. Okay, and then that should equal 18 times A. So 18 times 2.606. And that equals 46.9. Right? So plug in this value of T into that equation, plug in this value of A into that side there, right? And these guys should be equal. And indeed, I get the same number, right? So that's a way to check it. Okay? So step one, just calculate obvious things like calculate force of friction, or if it's an inclined plane, to find the parallel force, right? If there's something hanging on a string, there always is, right? Find the weight of the object, right? Decide which way you want the system to accelerate. Now, it's obvious that this one's going to accelerate this way if it's sliding that way. You're told to do that, right? Set F equals MA. There goes the dog. Okay, F equals MA for both equations, right? And then you can always just add them together and solve. You always get a solution that looks like this. It's always the force causing the acceleration minus the force preventing it. over the sum of the masses. That'll give you the acceleration. And then plug in to get your tension, right? And then once you have the tension, plug it into the other equation that you didn't use, and solve for both sides and make sure that it equals. And then you'll be sure that you've got it right.